It was created by Google in 2003 and 2004, called Google Borg for the internal system. If you want to know how many containers Google runs today, they're running around 14 billion containers for all their products to make it work in production. We can't even count how much they have in the lower environments. Then 2014, they renamed it as Kubernetes. Kubernetes means helmsman. Then 2015, they donated to Cloud Native Computing Foundation, CNCF. You all can go check cncf.org. When we started Java, I went to java.sun.com almost every day to see the changes. Similarly, if you want to excel in cloud computing, cloud native application, you have to go to cncf.org every day to see the new projects, what they do, and simply follow them. You'll be fine. So I put two analogies. Kubernetes is the gun, and containers, the bullets are containers. The bullet has a shell, it has a gunpowder that has that poison. But simply having a bullet will not help you. You need something to operate it, that is gun. So what the gun does, the gun hold the bullet, very first thing, hold the bullet, fire the bullet, take the direction. It has a pump that gives velocity to that bullet. It also has a chamber to empty the bullet. So it does, 7 to 10 different things to the bullet. Similarly, Kubernetes does around 70 different things for a container to be operated. Second analogy is the orchestrator. In the musical group, right, you see everybody has their own instrument. By playing one instrument, you don't get full music. The orchestrator is the one who combines all those musical instruments and give you the unified music. So look at this one. We call it like container orchestration. Many of you know cloud orchestration. I can tell you what is cloud orchestration in simply. If you want to create a Apache web server in the cloud, you can go and use the PaaS service. You can just go and initiate the PaaS service. That's it. Behind the scene, it creates a VM for you. It stores the VM at the storage, allocate IP address, put them with the appropriate subnet, and bring you outside of the network. So all those things are happening like a music, like an orchestration. That is cloud orchestration. Similarly, Kubernetes does container orchestration for containers. It provisions the container, it does deployment, it allocates an IP address, it allocates services, load balancing, it allocates high availability, and also gives enough security and monitoring. So you can do anything with Kubernetes. Remember, Kubernetes is extensible, meaning you have a dining table, a fancy dining table. You can buy it, but when you want to expand it, you can pull them out. It will expand automatically. So you don't have to wait for a new furniture that comes with a particular width. That's an example. So here, Kubernetes, you want something to be done, you can write your own extension code on the top of it. You do not have to wait for the Kubernetes open source community to give you a specific version. So Kubernetes is extensible too. It has major portion, master node, worker node. And the left side, you can see kubectl. We don't say kubectl, we have to say kubectl. Kubectl is the command line interface that can run from your desktop or any machine. Kubectl controls the master nodes. The master node has all those components that will control and operate the worker node. From the developer perspective, you will say the worker node. The worker node has your application, that is container. In the Kubernetes world, we don't say container, we say pod. So kubectl, command line interface. And Kubernetes objects, we have several objects, and once Joe will send the presentation, you can all read about the objects. I gave enough links at the end of the document. The primary thing here is a pod. Pod is the basic unit of work in Kubernetes. A pod is the group of containers. So look at this one. I have a P pod here. So either shell, the green shell is the pod. Each P inside that one is a container. A pod has an XML IP address. It does the resource sharing and consumption with volume and networking. So basic commands, I have some references. Yeah, that's all. 8 minutes. I'm good. Any questions?
Lawrence, let me give about 5 minutes for people to ask you questions so far, and then we will hand it over to Atul. So Lawrence, one question from me to start with. Can the pods talk to each other?
Yes.
Okay.
We can call like container networking. You can do the networking between two pods if you want to transfer files back and forth. Okay. But most of the time, we don't do that in design. We use REST APIs for the application to call each other.
Okay. Thanks, Lawrence. Anyone have question?
Manoj.
Client node
Prabhu, wait. One by one. Let's go with Sunil. Yes, Sunil, go ahead.
Thanks, Manoj. Just a quick one. Is there a way I can get this slide? It's actually, the explanatory is very basic and straightforward. It goes to the mind. So the slide is really good.
Yes, Sunil. I will post that in the group chat as well as in the G drive. You will get the slide.
Thank you.
One question. Hello, Lawrence.
Yes.
Is it not? Hello.
Yes, I'm here.
Okay, that community, right? CNCBF, which I do not remember the name.
CNCF.
So that is for whole cloud, or that is for Kubernetes only? Because I saw IBM name is there. I'm working for IBM.
So the whole guys, right? The CNCF is a community created by IBM, Google, and these three guys, are pillars of CNCF. So they're funding this organization, right, to bring up cloud native projects. So okay, I have to type some errors. CNC.
Okay.
Okay, Cloud Native Computing Foundation. Okay, sorry, CNCF.io. CNCF.io. So these people, have a lot of incubation projects, and the classic project as a graduated projects, and first graduated project in the CNCF is Kubernetes. Then we have projects like Prometheus, Envoy, Container D, right? It is growing. And where you have to look at that, you have to look at the incubating projects. See how many projects we have. Usually, right, one of the project, right, will become very big in the coming days. So you have to keep reading them, understand which one will become big. Then you have to pick up from there. For example, Cryo is a big project. Helm is leading the market, right? So Link RD also came into this one. So look at CNCF.io frequently. Then you know where these cloud applications and the cloud is moving forward.
Okay, sure. Yeah, because that will be that is a good tool actually to know where the market.
See how many contributors? 84,000 contributors, right? And they also give you a free Kubernetes course. They have 120,000 or 110,000 approximately. Yeah, so keep looking at the space.
Yeah, thanks.
Okay.
Yeah, Prabhu, you have a question?
I just want to see a bit more in detail on the master node and client, the slide that was shown.
Yes, so this is where Atul will take it over from here. The idea here is most of the babies in the first session have missed Lawrence class, so I just wanted to give a refresher of 10 minutes from that. Okay, I will take the last question from anyone, then we will hand it over to Atul to give us the detailed hands-on demo. Anyone, last question?
Yeah, hi. Joe, one question from me.
Yes.
So, like, if we have one application with multiple services, it will be under a single service and multiple pods, or all are grouped together in a pod?
The whole objective of a container is isolation. You have to split as much as possible. For example, take a traditional VM setup. You put your Tomcat and the database at the same machine. What will happen? Tomcat always needs more scalability because it is a front-end one. A lot of users are coming in. It is not necessary all calls or goes to database. So whenever you scale Tomcat virtual machine, you're also scaling the databases. You don't need that. That is expensive. So what is the best use case scenario? Put Tomcat in their own VMs and put database at their own VMs. Similarly, you have to do some due diligence when it is in phase. Find out the components that needs more scalability. They all can go into set of parts. Find out the components that don't need a lot of scalability. That is the separate parts. So just one thing, we can define 100 different factors and to find out. But in a high level, you have to isolate as much as possible. Never mix it.
Okay.
The whole
Thanks,
concept of microservices.
Yes, sure.
Okay. So Atul, back to you.
Yeah, sure.
So Lawrence, thank you very much
so
for giving that introduction to all of us. Thanks for your time. I just looked to you suddenly without giving you any.
No problem at all. No problem at all. We have all the documents ready. Thank you. No problem.
Yeah, thank you, Lawrence. So let me just take over as we will just start and we will just finish off the slides.
So all of you, Atul is one of the key architect working for a multinational company, and he is having more than 10 years experience and working on all sorts of projects. During free time, he and me, we discuss about the best quality whiskey in the world. So this is one of his hobby. Atul, anything else you want to introduce yourself?
Yeah, sure, guys. So I have around 15 plus years of experience, and I have been working as a cloud architect in one of the organization. From the data center premises, I have set up good amount of data centers across the globe, and now we are working on the cloud platforms. So this is my a bit of profile. I have a LinkedIn account, and you can just reach out to me on LinkedIn. I will share it. I have been added to Joy's LinkedIn as well, and Lawrence. So I will share it after the session. So this is about it. Today's session, what we would be taking is a Kubernetes on Azure cloud platform, which is a service from Azure in terms of named as Azure Kubernetes Services. The competitors are Amazon Elastic Kubernetes Services, EK, and GK is the one which is the best at the moment, which is being used along with EKS. So Azure is also now picking up. Here it's a managed Kubernetes service where you do not have access to the master nodes, you have access to the worker nodes, which actually host the service. So if we talk about the cluster architecture here, right, you can see what is managed by Azure and what is customer managed. So on the left hand side, you see all the components in which we term as the control plane. They are managed by Azure and you do not have access to it if you are using the Azure Kubernetes services. The traditional way that is used in the data centers, or if you want to host your own Kubernetes services, you deploy master nodes in a series of 3, 5, or 7. That is the best practice that is being used in order for master nodes to work correctly and work in a kind of a good amount of fault tolerance and high availability. And so etcd, API server, scheduler, controller manager, all these are components which were described by Lawrence as well. And we only manage the worker nodes, which is on the right hand screen. It contains a particular components like container runtime and kube proxy, kubelet. We will come on to that in the next slides to just have an overview of it. Let me know if I can move forward from here.
Yes, Atul. So as I will be moderating the session, in between I will ask you to take a pause. But until now, then you can move forward.
Yeah, thank you, Joey. So this is about the control plane, which we discussed in the last slide on the left-hand side, right? So this is the heart of the Kubernetes. It's used for managing the worker nodes, and it has different components. And what is in brief, the role of the components, it's mentioned in here. So if we talk about the API server, it is basically used for as a management tool. So and all the kubectl commands and Kubernetes dashboard, they interact with the API servers, which is an API component, a service which is present on the master node. If we talk about the etcd, it is used for maintaining the state of a cluster, high availability, and etcd basically it stores the all the key value stores, and you also use it for certificates, hosting the certificates as well for for all the particular components, like for etcd, API, master, server certificate, client certificate, and scheduler certificate, and all along with the key. So in detail, if you want to study, but we in managed Kubernetes services, we do not have access to it. We cannot access it. Then there is a scheduler, kube scheduler. This is a service which is this is a particular component which is used to see which particular pod goes on to which workload. So if anybody is from the virtualization background, if we talk about, say, VMware, you can map it as the DRS in VMware, which is a distributed resource scheduler. That components also checks which particular virtual machine goes to which particular hypervisor, and how you manage it, how you schedule it, in the same way kube scheduler works in here in Kubernetes. Then there is controller manager, and it is used for replicating the pods. If the pod gets if the pod is getting damaged, then it will recreate it based on the replica sets defined into the YAML files, and also to handle the node operation. So I have mentioned in terms of Kubernetes, I have on AKS, I have mentioned one link in the reference. And just go to it. It will just explain what are the concepts in terms of the Azure. So if we go in here, so this is the very good article which explains each and every component. If you go in here, you will get each and everything from the Azure perspective. So I won't go in deep into it, but this is the link that I've mentioned. So you guys can just have a look and go through it. It's a very good particular link. Before I move forward,
I will take
a
pause here and go around. Anybody has any questions related to the control plane? Primarily the scheduler, manager, API server. I guess, Atul, most of the time as we get into this kind of projects in the future, probably it's very important for us to know a little bit more about this. Is that would that be a fair assumption?
Yes, we should know it, like what master nodes are doing in the background, how the things are happening, right? So we will come on to that, and probably when we deploy the stuff, right, we can just discuss. But from Azure perspective, if you are using kubectl, or if you do not have access to it, let me just show you few things, okay, before I move forward, so that we understand.
Sure, Atul. So before that, I'll just go ahead. Anybody has any questions so far?
think no. I will just show it.
Okay, Atul, go ahead.
So this is a test cluster that I created. I will create another one. So I have turned it off. Okay. And if I go in here, just a sec. So if you see here, right, this is a cluster which is created into the in AKS. And if you see here the node counts which have been deployed. So all these node counts that we have deployed, these are worker nodes. Okay, these are not your master nodes. You don't have access to the master node that we were talking. So to see the details of this particular scale set, it's a virtual machine scale set, which is used for auto scaling. So if we go in here, you see the 3 instances. These are in stop state. Whatever these are mentioned, node pool 1, 2, 1 under so and so. All these are worker nodes. Okay, so you will not see here the etcd settings in for the master node. You do not have access to it. It's all managed by Kubernetes. If it would have been managed Kubernetes, then you would have seen here 2-3 more VMs, and they would be master nodes. You could log in into it, or you can access it from SSH, and you can see what kind of namespaces are in there, where is the etcd files stored, where are the scheduler certificates stored, and all that you could see. But in here, these are the actual resources. When I say resources, here the pod runs. So you can auto scale it, or you can scale it manually, or upgrade it in the settings. If you go, you can scale it so that in order to revisit your workload requirements, if there is increase in the workload requirements, you can manually scale it. You can custom auto scale it from here. So this is how it is. So on that particular slide we were just talking, so this is how it is in the control plane. And if we need to go deep into it, there are a few other slides that I have. I can share it with you, how etcd works and the things. Just a sec. I may be having an article. Probably I can share it. You can just have a look. It's a common common thing over there. So let me any doubts or anything that you want to know at this particular thing on this control plane? Okay, so let me move forward. So as we discussed, Azure VM, as mentioned, it's a worker.
Hello, Atul. I think we lost you. Atul?
Yeah, I think the call is lost, I believe.
Yeah. Let's wait for him. Hi, Atul. We lost you. Okay, let me call him on his cell phone. I'll be back in a moment. He lost his connection. So folks, give about 2-3 minutes. He will join.
Hello, am I audible now? Sorry, my connection got lost. My router rebooted. Am I audible?
Yes, you are audible, and you lost your connection. For that, you have to pay $3,000 US.
Oh man, is it okay? I will pay.
Okay.
No problem. So let me. You can see my screen, right?
Yes.
Okay. So we were on here. Yeah. So as we saw, this is a worker node is a VM, which is Ubuntu or 2019. So currently these are the two options which Azure AKS provides. So in this session, we would only be discussing about the Ubuntu Linux. On 2019 worker nodes, it's for Windows-based containers. So that's a separate thing. So we will not be covering that. Second point is the component on the worker node, which is kubelet. It is hosted whatever you load, whatever worker node you use. This is the component which needs to be there, and it interacts with the control plane, that is the master nodes, and for scheduling the requested containers as and when request comes from the master nodes. Every worker node has a container runtime. It could be Dockers, or it could be Rocket, or it could be in AKS in official documentation. If you go through it, in AKS, Moby is used as a runtime container runtime. And if you use other than Moby, you can use an AKS engine to configure and the Kubernetes cluster. But generally, this comes up, and this is being used. Now, the important part here is the networking. So kubeproxy is a component which handles the virtual networking part. Now, networking is a bit of complex stuff. In here, in networking, that we will be discussing in the coming slides, we would be using two types of networking. One is the default Azure-based KubeNet, or other is a Calico-based or a CNI-based networking. So we will come on to that. And if you see on this slide, you will see Azure disks and Azure files. So in Kubernetes, for the application which required the volume shared storage, or the shared persistent share volumes claims, there you use Azure disks and Azure file shares for placing the data for the applications. Say for a database server, you create a file share or a disk, Azure disk, managed disk we talk, and then you mount it as a persistent volume for the shared storage. All these settings are defined in the YAML file when you provision a pod for that particular application. Interaction of kubeproxy is with the VM NIC, which is the kube worker node NIC, and it connects to the Azure virtual network. In other particular cloud environment, it would be VPC in say Amazon, or in GKE. I will take a pause, and if there are any questions, just let me know. Okay.
Adil, this is Dinesh here. So it's regarding the kubeproxy. So is it just a process, or it is also a kind of VM or container?
It will be a kind of service, and this service is hosted on the kube-system namespace. Okay, we will see that. We will see that when we do the demo. We will just check it out where it is present. Right?
Sure. Thank you.
Thank you.
Hi, Atul, Deepak here. I have a question. We are referring this control plane as a SDNs or APIC, something like that, or just wanted to understand on the networking part.
The control plane, right?
Yeah, the control plane. we have this networking as SDNs, or the term like control plane, wanted to understand.
So this all is virtually hosted. So it all, whatever we are talking here, it's all virtual. It's all software defined network. It's all SDN. So so if we talk from the VMware technology or from other technology, like you have NSX, where you have everything defined over there. This is a control plane, which is a virtual control plane, and it runs on a virtual machine, which is sitting on top of the hypervisor. It could be Hyper-V or whatever is used in the data centers. So whatever we are using here, right, when we are talking this, so let me show you just a sec.
Yeah, you mean to say is there is, I wanted to understand, like on SDN, we said the virtual network. That would be what you call
yeah. So
overlay network, right? So,
so these are VMs, these are worker nodes, and these are all virtual machines provisioned, and all these virtual machines have a network, VNIC. If we talk about it, if we go in here, it's all virtual NICs, which are, if you see here, these all are virtual NICs, and they are bind to a subnet where these default rules are defined. It's all virtual.
So this would be NSXT, right? On VMware, like
yeah, it would be like VM NIC. This is VM NIC in VMware, right?
Yeah.
And this particular data, if it has to be passed to the outside world for the nodes, it will go through the hypervisor, which is underlying. You don't have access to it. You don't have access to it. So that's it. All virtual, sir. There is you do not have access. You do not have access to the data center devices in there.
Okay. Thank you.
Yeah, no problem. So I will.
Sorry, one question, right? If all these network settings are all virtual, right? So are they open to the other devices inside the network? Because you said, right, if they connect to the outside world, they have to connect to the hypervisor IP address. But within the internal network and the other machines in the network, or
device means this particular VM, right? The pods which are hosted, correct? If I say
correct. Yeah.
Yeah. So
but then in my organization, I'll have other servers, right? And services, like if I'm building a service here, I might build another application using these services as well. So
I will just show you that particular link that will help you in understanding. So there is a concept of network policies. Okay. So if you see this diagram, that will help you in understanding. See, this is just one of the kind. So when we come on to the network thing, okay, whatever segregation of network traffic we are talking, right? I will just show in here, just a sec. So all this thing, I will just take this example. See, it all goes through the virtual network. There is a virtual network that you create, right? And all the environment is isolated if we talk about the pod environment. So to allow the traffic, you have to set up the rules, okay, in the network security group, which sits on top of the VNet. Okay. If you go in here, this is my VNet. Okay. And in the VNet, you specify subnets. So whatever IP addresses pods get, okay, they get it from this particular subnet that you define. And whatever thing is there, these particular pods, if you say, if I go to their networking portion, it all goes through your all rules are applied, and through this particular network security group which is attached, it sets up the network security policies. Okay, and if it has to travel the outside world, you need to allow and deny the traffic, inbound and outbound rules you have to specify. It's same as you do into the virtual machine, nothing different.
I think we lost Richard. I don't see him in the list now. Maybe we will come back to this later on once he joins.
Okay. No problem. So these are the resources which are being used into the Kubernetes and the lab which we would be using. So I think they have been explained by Lawrence. I will not go deep into it. I will just only concentrate on to the 5, 6, and 7 points with in terms of terms, which is Helm, which is a package manager to deploy the apps. So we will be using Helm to deploy the MongoDB database as a pod on the worker nodes. Then there is an ingress application we would be deploying, and the purpose of this particular is to expose a service for external traffic to the internal ingress controller, which is a proxy service, and in here we will be deploying an Nginx ingress controller. So there is a reference link which I have mentioned. So this I think Lawrence has explained, so I won't dig much into it. I think Richard has come. In case he has some questions, Richard, where are you?
Yeah, sorry, I got too excited and it dropped, and it took me quite some time to reconnect.
Okay, so
I'll take the link offline from you, or if you can just post it in the group chat, right? I think I'll read up on that.
Yeah, sure. I will share all the contents with you that will help in understanding.
Thank you so much, and really appreciate the session. Thank you.
No problem, sir. Thank you.
Hi.
So
Hi, Atul.
Yeah, hi.
Helm, exactly what does do Helm?
Helm. So this is okay. The application deployment or on the pods that happens that is being done by Helm. It is also a way of doing it. So it is a managed. It's a package manager which is used to deploy the applications. Other than YAML files where you use kubectl, you can also use Helm.
Okay, fine.
Thank you. Okay, so generally in this particular lab, we would be covering similar kind of environment. I will show you the architect diagram, but this diagram why I mentioned is in order to understand what we would be doing. So in terms of understanding the ingress controller and stuff. So the load balancer, the user hits a request, okay, and it hits the cloud load balancer, which has a public IP address and which is registered into the domain registrar. It could be this load balancer, it could be your on cloud, or it could be on your private data center, and the DNS record can sit up in anywhere, whether it's GoDaddy or some other DNS registrar, which provides you the DNS space. And from the load balancer, it hits the ingress controller service, which resides in a namespace, which we discussed. The namespace is a logical thing, logical stuff in which your resources sit. Okay, so from this particular service, if you see, this is a namespace, and from there the traffic can go to the underlying pods which sits in a different namespace. So this is how the environment we would be setting it up. We will be just discussing in the coming slides what would that be environment and what we would be using. So the funda is, whenever we are creating something from the Kubernetes or the thing, if we are specifying something in the YAML as a kind as load a service, and then we put it up as a load balancer or a particular service type as node port, it all gets interacted with the cloud provider, and it creates, suppose we set up, put it as load balancer, it will create a load balancer into the cloud platform automatically and assign the public IP address to that particular endpoint. In this particular lab, we would be using layer 4 load balancer, and along with that, we will be using Nginx ingress controller. However, if we are using layer 7, which is an application gateway, which is a more intelligent load balancer, there you need not deploy the Nginx controller service. So this is the networking part. So Richard, probably you can also go to this particular slide, that may help, and I will share the link. So as we discussed, there are two types of networking which AKS uses. One is the basic networking. In this, we will be covering the basic networking. The one which I showed you, it's an advanced networking where all the pods would be getting an IP addresses from the particular pods which sits in the Kubernetes cluster. Here in which I deployed, I used Calico, which has a which has direct support from Microsoft, inbuilt support from Microsoft with Azure CNI. So when we will be using KubeNet, it will be creating everything of its own, the virtual network, its subnet, everything of its own. But if you need to go to advanced, you can do it via Calico or some flannel if solution being used. And the traffic, if you see in the below, it's a KubeNet, which is a basic networking. And in order for pods sitting on node 1 to communicate with pod on node 2, you need to use NAT, which then traverses the traffic from the virtual network to the other node. So the if suppose pod look at the lower diagram, if 10.2.4.0.2 had to communicate with the pod 244.1.2 on node 2, it will be done through NAT and routing via KubeNet, and then that particular traffic passes from the virtual network layer, and then the destination is detected as node, and then there it goes to the NAT of the other node, and the traffic is to that particular destination pod. And if you are using CNI, then it uses the bridge network, as in the traditional Kubernetes networking. If you must have seen those kind of videos, it uses a bridge, which is a kind of a bridge network that gets created onto the node. Same as into the Linux, you use bridge. This is the another way. But if you put Calico on top of it, then it creates a VXLAN on top of it. So the traffic is transfer from one pod to another is a bit easy and much more organized. And in there you use network policies of your own. You create your own, but in the basic one, it all creates automatically. So we will be talking about this one because it's a lab environment. And if you are using a Calico based networking, then it requires a good amount of planning, all the in reference to the environment. So these are a bit of basic differences on a high level, where to select KubeNet and where to select Azure CNI. If you require more IP address spaces, then go for CNI. And if you require for if you want to conserve the IP address spaces, then you can use KubeNet. So this is the basic difference.
So Atul, a quick question is, as you are handling so many projects, which one is the industry-wide on the real projects, normally what you see more of a CNI than Kubernetes.
Yeah, it's more of a CNI.
Okay, thanks.
It's more of a CNI. Yeah, so I have that environment, but that is a bit in order to make things faster and easier, I will be using the Kubernetes. In the next session, we will cover this Calico thing as well. I have that cluster, so after this particular demo, we will also hover onto that cluster and see what is the difference between the two.
Sure, Atul.
In this, yeah. Thank you. So let's go into the lab. So what we would be doing is we would be creating applications on AKS, where we would be deploying a MongoDB database, a public front end, which will hit the ingress controller, and the order capture API, which will interact with the Mongo database and picks up the secrets from there in terms of username, password, and hostname, and it will make a connection to the database for the same. So this is what we would be doing, and the prerequisites that you will require in order to achieve that is you require an Azure subscription, whether you can use a free trial if you don't have any, and you can have Azure CLI installed or Azure PowerShell installed on your desktop. If nothing is there, you can use Azure Cloud Shell, which contains most of the things, and like kubectl, everything gets loaded on top of it, and Helm is also present on it. You need to update the repository for Helm. A basic understanding of load balancer and a basic understanding of containers. So this is what we would be trying to achieve today in the lab. Like we would be deploying this particular architecture, which is being shown. If you see onto the right hand side, first we would be deploying the MongoDB database, which will be storing the orders. Then we would be deploying the capture order API, which interacts with the MongoDB database. It will have two pods, and in front there would be a service, and this service would be exposed to the outside world through the load balancer. Now what I am talking here is all load balancer, everything here is virtual. Okay, it's all hosted on Azure, the Azure load balancer service which is used. And also this load balancer will also be traversing the traffic to the ingress controller, which will be actually be the front end. So there would be two public IPs. One would be for ingress controller and one would be for capture order service, as mentioned. Now this we would be deploying, and from where I have picked this, there is a link which has been mentioned, aksworkshop.io. Everything is listed over there, so I have picked that use case because I found it interesting, and it would be a good way to show how we make use of AKS in terms of deploying the environment, and how it integrates with the cloud service to make things easier for the infrastructure application people and also for the end user in order to manage it. So let me know if any questions you have in here before we move forward to the lab.
Yes, maybe Atul, since you have been talking, we can give you a 2-minute break. And then we can start. So what you would like to have during your break, a vodka or a red wine or a single malt on the rocks?
I would prefer single malt on the rocks.
Okay. I'm sending that through a pod, which will get deployed to your container. If the glass is there, it will deliver there.
Yeah, sure. I will just be back after finishing it. Give me 2 minutes.
Yeah, sure. Okay, Bharat, you joined. You are you the new guy who joined recently to our group, or you are the storage Bharat from the earlier group?
I am the new Bharat.
Oh, you are the new Bharat. Oh, okay.
I work
Okay.
I work with Atul.
Oh, okay, okay. Got it, got it.
Yeah.
I'm back. Sorry.
Yeah, Atul, we can proceed. We don't have any question in the meantime.
Okay, great. So these are the commands that we would be using. So this is just for the information. So let's get started onto the lab. So you log into the portal with your credentials, right? And the first thing that we're gonna do is ignore these. These are we will be first creating a resource groups, and in the resource groups, everything will be stored. So we have one resource group, KG, RG, Kubernetes, and MC. This creates automatically when we create a cluster. So we will be seeing one by one what we're gonna be doing. We would be using the Cloud Shell, which is here. Okay, so you launch it from this particular button. It's a common thing in all the platforms. So I would be using this one, and I have a shared storage. And if you see all the files which are required, I have pasted it here. And this particular site I was talking about, so we would be deploying this. So I will just paste it into the chat so that you can also have a look at it. And it's quite a good site. Similar kind of site is there for Amazon as well. So when Panish would be taking a session, he would be showing that. So what we would be doing is, let's see, first, just a sec. So first we would be doing is seeing the version of AKS, what we would be using. So this is the command that you're gonna be use. Just a sec. Oh, we need to specify the regions. Sorry about that. My bad. I will specify a region here. So we would be deploying everything in East US. So if I do the region, so it will store this into the variable. So this is the Kubernetes version that's we gonna be using. Somebody is pinging or what? Anyways, so then we come on to we will create a resource group. So I will be creating a resource group with the name of RG2 Kubernetes in East US location. So this is how it's going to be creating, and it says succeeded. If we go on to the portal, if we refresh it, you can do it all such things by GUI as well, right? But we would be using the commands line for this. It takes a bit of time sometimes. Azure just takes a bit of time. So this is the resource group which has been created. And other than this, when we will be deploying the cluster, it will create a resource group MC_RG2-Kubernetes and the cluster name and appended with the region. So let's create a cluster. So this, if you see, before I go in that, okay, there are we need to understand the command, what we exactly do. So if you see, there are different ways to create a cluster and different types that you could use. One thing is that you create a cluster without the autoscaler, right? Recommended if you are using a lab environment. Other solution is that if you have your own subscription, you just go with the simpler one. It's a simple command, it will create it automatically. And if you are using an autoscaler, you need to specify all such commands in there. So let's talk about this, what it creates. Here you create a cluster under the resource group that you created, right? You give that name, then you specify the cluster name that you want to give to the cluster, specify in which region it will go. Then the version that you created, the dollar version that you created, so it will deploy a cluster of this particular version, which is 1.17.3, which is the latest version present in that region for the Kubernetes. It will also generate the SSH keys, which is required for the cluster. Then you make this cluster as the worker nodes in virtual machine scale sets, which is used for auto scaling. So all the nodes would be part of the scale sets. This is a concept which is popular from Hyper-V. There also you have scale sets, and then you specify that you need to enable the auto scaling on it. You specify the minimum node should be 1 and maximum should be 3 that we would be using. Use the load balancer SKUs as basic. There are different types of load balancer SKUs that you can check. Then it also create the service principal automatically, and also set up the secret. Now here, when we say that it's gonna be creating it, if you are not even specifying it, it will create it automatically. Okay, so where it will create? It will be creating the service principal which is required for connecting your Kubernetes cluster. So it will create that particular thing into the application registration, app registrations. If you see in here, so when I deployed that cluster, it deployed this service principal, and it has got the rights as a network contributor role that I provided. So this is created automatically when you are using it, or you can specify it manually. So this is the app ID and everything for this. So if you are thinking where the service goes, it goes in here. So let's have a let's see how we do it. So let me create a cluster with under this resource group. This will be the name of the cluster, and it will take the version, it will generate the SSH keys and auto scale and all.
So this looks like the CLI command of all these cloud providers.
Yeah, it's Azure CLI. It's Azure CLI. When you use the Cloud Shell, all these comes automatically. And if you see in here, if I do ls, right, whatever files that I have stored in here and what are the public keys that I'm using, they all are mounted to a file share. Okay. If I say in here, I have mounted this particular file share to my this account. So everything goes in. Even I reconnect the session, I will get all the files. Okay. So even in this particular thing, if you go, so when you first log in and you click on the shell, you select, say in this case we select the bash, and it will ask you whether you want to create storage or not. You select yes. Even if you have not created any storage, you can create it later as well with these particular commands that you can use. You can mount it with this command. You give the subscription ID, you give the resource group name, which is RG Cloud Shell, you give the file share name, so you give the
Hello, Atul. We lost you again. Atul? Anybody else able to hear Atul? I guess no, right?
No, I think we lost him.
He's calling me on my cell phone. Give me a sec. Yes, Atul? Okay, okay. Sure, no problem. We lost him. He just called me on my cell phone. He's joining in a minute. Got disconnected. So while he's joining, let me take a survey from around the world. What I'm hearing from your respective country folks that due to this situation, you guys are experiencing a network bandwidth problem at your home, internet speed, slowdown. Is it becoming more and more painful? So I'll start with US. How is US in this situation? Is it the speeds are decreasing day by day, or it's kind of a known issue for you guys, whoever is from US?
No issue.
No issue. Okay. I think Lawrence from Canada says he's bit impacted because of the slowness. Would that be correct, Lawrence?
Yeah, that's correct, Joe. Mostly, during the evening time, everybody is at home today, so the bandwidth is going down. I'm telling people, right? The internet may in 2-3 weeks if it continues, right?
Correct.
So some cables.
Yeah, so it got disconnected. Even there was
Yeah.
there was a kind of power fluctuation that happened.
So Atul, while you were connecting back, I was taking a survey, world survey, and folks were telling that they are experiencing a slowness, bandwidth is going down, except Joyce, because Joyce is in a city. The city never sleeps and it doesn't allow you to sleep. So she is in New York, so that's where New York is. So she says that nothing, it's all normal. Okay. How about India, folks? Okay, that's what you Atul, you are experiencing a little bit of fluctuation, right?
No. This is not a problem with the internet or something. I have got a good plan. Only thing is that I do not have a UPS connected to my router. So when power fluctuation, just give me a moment, guys.
Okay.
India also the same situation. India is the India is the lockdown. So all guys are working from the home.
Okay.
Sometimes internet speed is good or sometimes it's not.
Okay. Hey, Arun, where are you from? Which country you joined us from?
Hey, hello, Joe. I joined from Germany and I don't see any internet issue. It's working perfectly.
Oh, okay. So you are the friend of Dinesh, our Germany Dinesh.
Okay. Yeah. He called me around 4 o'clock. It's around 5:15 over here now. He called me. I was sleeping. Somehow I woke up and then he told me that this is going on, please join. So I joined it actually, and I find it very interesting. Thank you, Joe, for organizing this, and thank you, Atul, for contributing to this.
Thank you, sir. It was nice to hear from you. Thanks for your compliment.
Thank you. Thank you. My pleasure, Joe.
So for our group, I am a policeman also. So whenever I see some names, I just try and investigate. So your name came. So I thought, okay, let me ask you.
Sorry about that, man. So there have been so many calls which are coming up.
So many calls from
Okay.
where? From ex-girlfriends or the future girlfriends?
I got a call from office.
Okay.
Anyways.
I was kidding.
So where were we? Yeah, here. So let's create a cluster with the command sets we discussed. So we would be creating a cluster in this resource group that we created. The name of the cluster would be this one. And we will be enabling monitoring. We will be using the, I think I need to again do it. Sorry. I will create a variable and I will place it there. Just a second.
So Atul, while these commands are executing, a quick question is: the folks we can try in our Azure free account, right? We no need to get anything specific at this point of time for this lab, or do you feel that we may need to spend some amount of dollar while practicing this?
No. Even if you see, the charges are not that much, because even if I say I created the cluster, okay, so I only the only charges that I got was around 200 rupees or something.
Sure.
But that is my subscription. But yeah, this is the link, right? So if they have mentioned in here what you could use and what you cannot use.
Sure.
AKS on your own subscription. On your own subscription. If you are using a free trial, I think free trial you get credits of 13,000 rupees. So you can practice it for that for 1 month.
Sure. I think I would encourage everyone to, even if we have to spend about, let's say $20-30, if it is, then I would encourage everyone to try this, because what Atul is showing us, it's very different. You won't get this kind of session with this much clarity in all those video courses or all those training institutes. So I would highly encourage, if you are trying and if you have to spend about some money, then go ahead and do that. And I think that the learning will be more effective in that sense.
Yeah. So if we see here, right, so what it is doing is it is what it's doing in the background. So it has created this service principal. If you see, if I hover onto that command, just a second. Okay. It created a service principal first. Now it's in the process of if you go in, this is a service principal which has created, right? And it is managed application in local directory. This is your Kubernetes cluster. So it is doing it automatically. And what else it is doing, we will see. It would be, we go into the resource group, and in here, it will creating the virtual network as well. Everything it's gonna be creating. If you see, this is the cluster which is getting created. And if you see, it is the network plugin type is basic kubenet, right? And it's a 1 node pool with 3 nodes getting deployed. This is the node pool, and this is the Kubernetes version. This is the size of the node. So it's in the creating state. If we talk about networking, it will all set it up by default. Okay. So if you see in here, it would be the service siders. It would be using this, and the Docker bridge siders, to which the pods would be getting this IPs, containers would be getting these strange IPs. But before that, I will show you the nodes as well. So If you see in here, it also created this cluster, this resource group, which contains other settings. Like it will create a public IP address, it will create a network security group, it will create a route table, it will create a virtual network, and a load balancer for Kubernetes. So if we go in here, if we look into the address space, this is how it is. This is the address space. And if we go in here, this would be the subnet. This is the node subnet. Okay, this is the subnets created, and automatically this particular NSG is attached. This particular subnet gets associated to this network security group, which is used for the rules. So all this happens automatically when you are provisioning it. You can do this in the GUI way as well, but this is the better way to do it. You can put it into the scripts, and you could do it. You can use it such kind of things with Terraform or some other deployment tool. So this is the use of the CLIs. You can integrate it and minimize the GUI use as much as possible.
And then this is where my next question, Atul, is, as I noticed, it's still running the script. So is there a benchmark that such kind of script takes about, based on the requirement and setup on the background, what's the average execution time of such scripts? Or is there any benchmark, or it all depends on how much resources you are going to define inside the script? Based on that, it will take time.
Okay, so let's take an example. Okay, so if there is a script which would be doing all these things that we're gonna be doing, you put it into one script, right? So as you see, cluster creation takes time, and but if we are talking about the pod creation and all such things, that won't be taking much time. So it all depends on what are the contents in the script. You can also put these things in the pipeline, Azure DevOps pipeline, and you could use it. So it all depends upon the content, what is the size, whether you are putting the data as well into the file, or if you are using an existing data. So it shouldn't take that much time if you are into the provisioning state. If you are retrieving something, then how much are the queries being run, that depends how much time it's going to take. So there is if you're talking about this particular lab, it's going to be deployed in say 5 minutes. This particular command will be completed in 5 minutes, because it would be doing a lot of things. Reason being is that in creation, load balancer takes a bit of time, right? This load balancer creation in Azure takes a bit of time. I think it's in everywhere. It takes time. Like if you deploy application gateway, or if you deploy load balancer, or if you deploy any PaaS service which interacts, which has certain dependencies. So it has completed now. So once it has completed,
one thing, Atul, I noticed that you are creating all these resources in the US East region. Do you think, by any chance, while the script is executing, is the network latency could be one of the contributing factor for the execution, or not at all? It doesn't matter wherever you can create.
It doesn't matter.
Okay.
It doesn't matter. So you are making a connection. This connection is to your Cloud Shell. So it's a kind of temporary VM which is hosted on the Azure, right? If I have initiated this particular command, this will run on top of it. Even if I lose the connection, this will still run, and it will complete. It is not from my machine, right? If a connection has been made, it will deploy it automatically. It will deploy it. Even if the connection gets killed, it will still run. Suppose if at this moment my internet connection goes down, it will still initiate, considering, because it will keep on running. The process has been initiated, right?
Correct. So the reason I was asking this question is, some of our babies went to an interview groups, and they pinged me offline, and they were telling me that they got questions from the hiring managers about the execution speeds and all those things. They were interviewing around that. So it's a good clarity to that.
Question. Yeah, execution speeds may come up. They may have been asked question related to the migration, right? if you are migrating workloads or the environments from one particular estate to the cloud service, then that question may come up. I'm not sure whether it is the one, but that question may come up at that time. That
Absolutely,
if you have
you
to
are right actually. So some of the folks which I've given, I'm working with them offline, Atul, to get all the interview questions, and then in the future we will set up a brainstorm sessions. I will invite all of you as our mentors, and then I will walk through all of these interview question sessions. So the just now what you mentioned about the migration question, yes, it came up with somebody who went to for an interview. Uh, he was pinging me offline, and he told me that okay, this kind of questions he's getting as he's appearing for the interview.
Okay, so now this has been done. So what we would be doing is, now we will be getting the credentials. These credentials are required so that we could connect to the cluster using kubectl. So if I go in here and if I try to connect, okay, to this, so it has created the service principal, and it says it's not ready yet. Just a sec. Just give me a moment. Let me see which particular cluster it is connecting to. So this is connecting to the old cluster, okay? So I would be the cluster which I used. So I would be using this particular credentials to connect to this cluster with this service principal to this resource group. Okay, now it has picked up. Now if I go to kubectl get nodes, so if you see, now I am connected to this kube cluster through the config file, right? So if I go in here and if I show you, so if you see with this name, right, this is the node name, and if you see, this is being used. Okay, so if I show you this, you can see it. Just a sec. Right, so these are the nodes which are being used. Earlier I was connecting to this particular cluster, which I got connected via a different service principal to a different resource group and a different cluster, the other one which I showed you earlier. Anyways, so let's see what we have at this moment. So if I go to kubectl get pods, so I would be checking it in all namespaces. So currently there are no pods which are deployed into the default namespace. So all these things which you see, they are in your kube system. Now we were talking about the kube proxy a bit back, right? So kube proxy has been deployed as a 3-pod in the replica set in the kube system namespace. Somebody asked this question. And if you talk about the OMS agent, this is the agent which is used by Kubernetes to monitor the nodes and the pods. Sorry, not the pods, but the nodes. OMS agent. This is the Microsoft monitoring agent, Microsoft Azure monitoring agent, which is loaded. And This is how, and the core DNS is a normal, which comes up, and there are other pods. So let's move forward and let's deploy Mongo database. So what would the name? But first we have to just see whether we have an updated Helm or not. We will just see if we have Helm here. So yes, it's loaded. So if we gonna read, so it says it's a Kubernetes package manager. It uses for upload the charts to Kubernetes, or it's a package manager. So it gives you a bit more much information as well, what it does and all. So you can just there is one site as well, I will share with you all the links post this session on that. So this is the version of the Helm that is being used. So it should be 3. So if we have an updated one, we will add a repo for the same from the Kubernetes charts, this APIs. It has been added. Now we will update the repo. So we will just see whether it's updated or it's the same. So it's the same version, no different. So it's already updated. So now we will deploy the MongoDB to your cluster. So rather than this, I will just come in here. Okay. So this is what it says. So you need to deploy a Mongo database in a way, scalable, production ready. Just forget about this. So use Helm as a standard provided Helm chart to deploy MongoDB. And here we would be using, this is the solution. So here what we would use is, we would be using Helm install. This is the orders Mongo database. And here we will be setting the username as order user, the password. In general, you shouldn't do that, but this is a test environment. We are doing it. Else you can use the secrets, Azure secrets or the Kubernetes secrets to do that. So we would be deploying in this way, considering the thing. And once it is done, the Helm chart will expose the database at this particular record. So it says that to connect to your database, what does it say? So it has created, it is into the creation stage, this particular pod is into the container creating stage. So let's wait till it finishes, then we will see. And once it is created, we will be creating a Kubernetes secrets, so that whenever the connection is made to this database, the application picks up the secrets from the Kubernetes secrets. So we will be storing all this information which is in here to these secrets. Guys, hope you are getting what I'm showing, or probably you may have done it as well. I'm not sure. Are you with me?
Yep.
Yep.
Okay. Still in the creating stage. So just wait for 1 or 2 minutes while it gets created. And this particular pod is getting created into the default namespace. So it has created. Now, now what we would be doing is so if you see in here, this particular command has also created a MongoDB IP, the service IP, which has been created along with this. Okay. So let's create these secrets, and for this particular orders MongoDB, for accessing the MongoDB databases, let's create these 3 secrets in the Kubernetes cluster. So if it has been created. Now if I have to see, so this is the command that we use. So these are the secrets which have been created for in here. Okay, so if you see in here, Mongo DB fake, and these have been created in as secrets. So till now we have done this so far. We have created a secret, we have created a pod, we have created a service, we have created a deployment. So we created one deployment which contains a container, and also we have created one service. So to a brief description, the pod holds the Mongo database container. The deployment is used for managing the pod, and this particular service, it exposes the pod to the internet using public IP and a specified port. Now what we would be doing is we would be deploying the order capture API. Okay, so what it will be using is this particular API. When a request is hit, it will connect to the secrets and it will make a connection to the Mongo database. So here there is a container image, public Docker image, which is present, which would be used for the connection. We would be deploying this particular pod via your YAML file. So I have got this YAML file ready. So we will see the contents of the YAML file, what it uses. Pardon. So what it does is it creates a container with the name of capture order. Okay, this is a template. Generally, the YAML file has this particular base format, API version. Here we are putting it up, kind deployment, which is for managing the pods. Here we are mentioning the data, metadata, capture order. This is specifications for the particular resource that we are deploying. And in here, we are setting up, okay, then there would be 2 pods that would be generated, that would be created, a replica. This is known as replica sets. And then here we define the template. What we would be doing under template, we will be specifying the container. Okay, in container we would be saying that the name of the container would be the same. And this container will be made from this image, which is public image from Dockers, and it will be via pull method, not a push method. And then it will be creating so and so things under it, under the readiness. Then we would be specifying what would be the limits that this pod each pod will use. So it will be consuming maximum of 256 MI, and also the CPU usage would be 500 units that it should be taking. Also, with this particular YAML file, it will be setting up the environment variable. So what it's going to be using is, it will be setting up the environment variable when the request is made. It will pick up the secrets from the Kubernetes secret with this name, and it will pick up this key from there, from the secrets. So this is how it is used, that we will be using it. So I have already created this file and pasted it into the shell. So I would be deploying it. I will just show you where it is placed. So if I, okay. So if you see in here, we have a file named capture order deployment. Okay, we would be deploying it. We will be using this file. So in order to run this file so that it creates the deployment and all the pods and underlying environment to it, so we would be using this command. So it's a quite a common command, and it was also shown last time. So if you see, this has been created. So if we see here, it has created the capture order pods. So there are 2 pods which has been created under the replica sets as mentioned in here. And if we gonna see the detail of each pod, we can mention it as so it will give you the detail what it does and what is the what the thing it is there in here, like what when it was created, when it started running, and what is the ID under Docker, and which image it pulled, and what is the port it would be open, what is the limits 500M, whatever we specified in the YAML. So all things will be shown in here. So when we talk about the environment, Mongo hosts the 3 variables, the 3 secrets that we created, it will pick it up from the keys. So so this is about it, and let's move forward. Now we will expose this particular deployment, that this capture order deployment with the service. So we would be exposing it to a load balancer type. So here, when we say load balancer type in here, as soon as we run this particular YAML file, this will create a load balancer in Azure. So how we would be doing it, I'll just show you. So if I go in here, okay, we currently see a public IP, one public IP, which is for the Kubernetes. So as soon as we deploy it, this YAML file, it will show up few more entries for this public IP. So let's go in here and create it. Just a sec. So I have this listed, already pasted. So capture order service. So if I go, sorry, if I go in here, this is a capture order service YAML file. So we can, it contains all this content. So all the 4 things are same. Okay, the kind changes to service, and the specification, the selector, application, capture order, and the ports it's gonna be using is port 80, and the target port on the pod would be 8080, and the type would be load balancer. So it would be hitting the pod load balancer on 80, but it will then internally it will connect to redirect to port 8080 on the pod inside the cluster. Okay, so we will go in here. First of all, we will just see the content of this file.
Hi Atul, sorry to interrupt you. So hello.
Yeah.
So we ran one YAML file before this service YAML, and in that there is a parameter readiness probe. Okay, and just wanted to know the difference between this service YAML file and the difference between the readiness probe. There is also, we have some ports mentioned over there.
Where you're talking? This one?
Yeah, the lengthy YAML file we executed before this YAML
This
file.
one, right?
Yeah.
Okay,
Yes.
this one.
Yep.
So,
So
these
here,
ports, these ports are for the application. So these are the sub ports, which are when you access the public URL, you can go to this path, post the public IP address, right? Post the public IP address. One, you can specify health to get the readiness probe and the health probe, liveness probe. So this is the sub paths that can be used, and these ports are on port 8080, and also the service will be interacting on the port on 8080 only. Publicly, when you access it via the public IP of this load balancer, it will, and you try to browse it, it will hit on port 80 on load balancer, and this load balancer will then redirect it to port 8080 onto the pod which sits on a node.
okay. Thanks.
So this is the content. So we have just used it and copied and pasted it. So we will be deploying it. So we will be seeing like what it creates into the load balancer, what it says, capture order. Okay. So it creates a service. So it has created a capture order service, which is a load balancer. This is a cluster IP, internal cluster IP, but it has also created, it is in the creating state. So external IT is yet to be pending because it's creating, it's picking up external IT, external IP from Azure. It takes a bit of time in populating. Okay, now we have this, sorry. So this is the public IP which it has come up. So let's see what it shows into the. So it has picked up this IP from the Azure load balancer. Okay. So it's the same IP, which is this particular public IP for the load balancer has been created. So it has created this dynamic PVC as well. This is a persistent volume claims. It is for the shared storage for the database, right? So whatever content users are writing, they will not be lost on the database even if the pod gets destroyed, because that data is stored into the shared storage volume connected to the pods which are hosting the MongoDB database. So it creates this automatically.
So when you said shared storage, is that storage is a persistent storage?
Yes.
Okay.
It's a persistent volume claims, which is the term used into the Kubernetes. So you can just Google around. So this is an attached storage. So this is a managed storage from Azure. So whatever data or whatever user requests are coming up, they are stored on this. Currently it has a size of 8 gig. It's a local, it's a cheap storage at this moment that we are using because it's a test environment. For the good environments or the production ready environments, you make it as per your environment and make the changes as per your environments. So it got created at the time we deployed the MongoDB database, right? This one. When we created the MongoDB and all, it created that time. Okay, so here we are on this solution. Now, this is also a command to retrieve the IP address. Okay. However, we can also see it into the external IP in kubectl get service. So it shows it in here as well. So let's paste it. This is also a command. It gives you the IP address. It's the same one, right? So now thing is that we just need to see if we are able to this particular hits the Swagger IP or not. So just a sec. So we have this IP, right? So it's a Swagger URL where you can just see the post and get of your storage. At this moment, there is none that you see. Now, if we go in here, it's an open API definition URL that's it mentioned. So whatever traffic is coming up, this is coming via public IP on port 80, but in the background, it is hitting port 8080 on the container. So it has V1 over order. Okay. So it says this thing, it has there are 0 count in orders. We see in here. Now what we will be doing is we will be posting a fake thing or on this particular database, and then we will again run it, and orders taken the form email address XYZ. We will just change it to something else. So what it would be doing is it would be posting this particular stuff on via API, which puts it onto the MongoDB. Oh, sorry. I didn't put the IP. If some noise is coming, I apologize, but this is how it is. Guys, hope I am making sense here, right? And I'm not boring you guys. Let me know in case you get bored or something.
No, absolutely not at all. Now, if I see, right, the folks are silent, that means I can assure you that 100% attention, everybody is listening. And as an assignment towards the end of the session, which you will give, and I will be the policeman actually. I will be pinging everybody.
Yeah, thank you. So if you see in here, we added one record and it showed the order count as 1 from 0, right? And let's see one more thing over the Swagger, what it shows onto the Swagger URL. So So if I add something more, so just a sec, if I add here something, okay.
So,
So there
Atul,
is
while you
another
are
order.
doing this, a quick question came up to my mind is, you are writing the CLI at the command prompt, and then you mentioned about the bash and PowerShell script as part of one of the UI screen. So initially, you prefer us to do this at the command prompt, and then after we get some exposure, then run it to the any script file-based script. Would that be?
Yes, actually it should be. Yeah, it's just to in order to understand like how commands work,
Sure.
right?
Sure.
But if you have to put it an end-to-end solution and at a faster pace, you can distribute this particular thing in multiple scripts, or even embed it into the pipelines as well. So I have my colleague with me in this call, Bharat Sabarwal. So I would be working alongside him in creating that and this thing into the pipeline.
Sure.
And we will maybe again demo it maybe next week or next to next week once we are ready, how this thing can be clubbed into a pipeline and we can deploy it using Azure DevOps pipeline.
Yeah, absolutely. Sure.
Yeah. So now we have two records. So it's a database is storing the information. So that having said that, that means the things are working. I'm not sure why it is not capturing the order here, but it is. Just a sec. Get. So anyways, so I'm not sure, but it is picking up the orders that we could see. Now we come into the last point. So we were talking about to accepting. Let's also see this, what it says. I think it's different. I think we haven't deployed it. Anyways, so now we have completed so far this thing, right? We have orders MongoDB, we have capture order API in two pods in the replica set. One we have one service and one we have one public IP for capture orders. Now we would be deploying the front end using Ingress. Give me 2 minutes. I will be back. Okay, give me 2 minutes. Thank you. Guys, I'm back. Sorry about that. So now we would be deploying the ingress controller and ingress thing, which is this thing we would be deploying. We would be deploying this portion, ingress controller and ingress front end pod with ingress service, front end service. We would be deploying this portion, and also we will be deploying one public IP for ingress controller, which is a front end and will be used to access the application. So it will all, we will be using YAML file, and what we're gonna be using is we would be using this Docker image. In the YAML file we will be calling it, and in the environment variable we would be using capture order service IP, which is the public order IP of this. We will be using the IP address that we got earlier from the load balancer in our YAML file to access. So here we are. This is our YAML file that would be used, and we would be using the root path here. We would be removing it as an endpoint. We will remove it, the readiness probe and all, and everything is same as we had earlier. Only thing, if you could see, is it's a kind of deployment that we would be using. There would be one pod which would be deployed. Name of the container would be front end, and it would be using an image, public image, Docker image from this particular path. Other than that, the limits are same as earlier for the capture order pods. And here we will be placing the IP of our capture order service IP, which is this one that we picked up. This one, this IP we will be using for capture order service. So before we do that, let me go ahead and create this file, front end deployment. So I will be changing the values here. Okay, I will save it. Now I will just see. So we have replaced, so it is coming up fine. So now we would be applying this. Here we would be deploying the pod in the deployment as a part of deployment, and post that we will be creating a service which will provision the cluster IP for this front end instead of load balancer. And after applying that, we will be deploying the ingress controller with Helm. Okay, currently what we are doing is we are deploying this portion. We are deploying this pod in here, this particular pod and this service. So we will be creating a pod which has a front-end app on it, and we will be exposing the service as well, which will be having a cluster IP. And post that, after this service is created, then we will be using Helm to create the ingress controller along with the public IP. Okay. So it is in the creating stage. So if we see in here, get service. So there is no service for front end. Now we would be creating the service for front end as well. But let's see if the pod has been created. So it's that pod is now running single replica, a single pod replica. Now we will be creating a service. And for service, we have this particular file. So it's a cluster. It's a service which we would be exposing to the cluster IP, and we would be basically setting up this front end service. We would be creating this, which would be a cluster IP, and it will be redirecting to the pod. This one, the front end pod. Okay, so we have this file present in the directory in the Cloud Shell. So it is front end service. So if we go into the service, so now we have front end service and we have a cluster IP as well, though it's not publicly exposed because this is an internal cluster IP for this front end application, which has a single pod. Now we would be deploying the ingress controller with Helm. So what we would be doing is this particular portion, right? This would be put it up into a different namespace. All these data, orders, MongoDB, capture order, service, secrets, for these are placed in a default namespace. So namespace is a logical boundary where it contains the contents for a particular set of pods or the deployments, right? Here we would be, for ingress controller, we would be using a different namespace names as ingress. So let's see, before we go ahead, let's see what are the namespaces we have. Sorry. So we have a default namespace. All these things that we have been creating in this, these are all system namespaces. So these we are not bothered. Now we will be creating a new namespace. So here we have the ingress namespace. Now in this namespace, we would be installing the ingress controller is deployed on this. And after this, a public IP address will be allocated. Now, when we say public IP address, it will be created on the Azure. So it will be using this image for Helm. So let's go in there, and it has created. Let's see what it says. Last deployed, just deployed, has been installed. It may take a few minutes for the load balancer IP to be available. So that's fair enough. If we go in here, on to Kubernetes portal, and so if we see, refresh it, one IP, this one is one, so it takes a bit of time to populate. So now we have another IP. So this is another IP, public IP, which has been created for this ingress controller. So let's see, let's see this IP via the command line. Let's try to retrieve it and match it. So it will be checking the service, but before that, we can also check it. So okay, why it's not showing here? Because it's in a different namespace. I will just show you. Okay. So if you see in here, it has created two services. Okay, one is the public load balancer, which has this IP. This is the ingress controller load balancer. This is a cluster IP on this, and it has also created a default backend with the cluster IP. These are two services which have been created as a part of deployment via Helm. So also we can match it in here. We can retrieve the IP from here as well. It's same, right? We have, this is the IP for your front end, which would be hitting the load balancer, and then internally this load balancer will hit this cluster IP for the service. So let's look at a few more things before we go forward. So so if you see in the load balancer how it is doing it, it has automatically creating the load balancing rules. Like this is one particular rule which is pointing to this front end IP, which is our Mongo, this one API IP, right? API IP. The second, and it is how it is connecting to this. Now the second rule which has been created on port 443, it's on your front end application IP. This is your front end IP. It's on port 443, so it's been accessed at port 43. And similarly, it has also created the same rule on port 80 as well. So it has created two load balancing rules for our front end application and one load balancing rule for our API application, which fetches or put in the information into the database MongoDB. Just to know like what it is doing in the background, right? Okay, now let's move forward, and this is now we will be creating an ingress resource. Okay, we would be doing an ingress resource. We would be deploying, which would be which would expose and the application to be accessed via this IP. So what it is saying is that we would be using our ingress controller IP, that means this public IP, to access the front end application. So, and it will then hit this load balancer and it will access it via this rule which is on port 80 that I just showed you. Let me see if I have this file or I have to download it. I don't know. Let me copy it. No, it's not there. So what I'm gonna be doing is I would be downloading it first. I will upload it into the Cloud Shell. So we will also see it's a simple way to upload. This is the point. Go in here, upload the file. Here you just put in this and it will show you here that the file has been uploaded. So this is my file and I will just copy this particular IP and what it says, you can remove it with your public IP. Front end. So here we are. I will just save it. So this particular is a service which is basically making use of the load balancer and the load balancing rule it is using. Now I will apply it. So it's been created. Okay, so this is, it has created this particular thing. So this is the host and this is the public IP which maps to this particular IP. So now let's see how the order changes. Now here we can open the web link. So it says healthy, right? This is the front end which says it's running fine. .nip.io. So even if okay, the hell is this? Okay, sorry about that. I have to make one change in it. I did it incorrect. Yeah. So I think I have to change it. I did incorrect. I may have to reapply the pod or delete the pod. Here I have to use front end dot. Okay, it says it's configured. So I will go to this, where it is. Probably it should display this order, so I may have to remove the pod and reapply it. Not sure. It's taking a bit of time.
That's fine, Atul. We as we move on, right?